Welcome to part 5 of Competency 9. In this video, we will answer questions relating to dual triangles and trigonometric functions. Number 1, look at the following diagram. Okay, so they give you a degree measure, and we have a length here, and then we have a full length from C to B. However, they say, what is the value of BD? So I'm going to call this X. Okay, we can use uh, the trig identities that we know, opposite, over, adjacent, and so on. But for this one, notice that we also need the value of A, because what do we need? Or we're going to go across from the angle A, and we go opposite that. We're going to call this small a, the length A. So how do we're going to need, to get X, this is what we need. X equals the 28 minus the A, okay? So we need to know what A is. Well, how do we solve for A? Well, we have opposite over hypotenuse. So we can use the sine of 30 because opposite over hypotenuse is sine. So sine 30 equals A over 20. So that's going to be pretty simple to get. Just multiply both sides by 20. Okay. 20 over 20 cancels. So then we have A. So what we need to put in the calculator to get A is simply the 20 sine 30. So pop it in the calculator exactly the way you see it. 20 sine 30 degrees is 10. So in order to get the value of X, now we know we need 28 minus the 10, which is 18, of course. So that would be option C. All right, now let's go to number 2. All right. Again, it says, look at the following diagram, okay? And it says, what is the value of B? Now, about that, here's our B. But notice that they want us to look for an angle, actually a degree measure. So that would be a theta. Okay, they want the theta of B. So they don't want the value of, say, sine B or cosine B. They will actually want the degree measure. Okay, so I'm noticing here that in this right triangle that we have, we can get this value here, the missing leg, okay? So let's call that, well, we could call it just about anything, but it's across from A. So standard math says call that little a, just like we did above, okay? So now what do? Well, if we get A, then we have this entire length. So we can use tangent or inverse tangent to get that angle measure we need. But we need A. Well, that's not a big deal. We can just use the Pythagorean theorem. So A would equal all under the square root. That would be 38 squared minus 22. Okay. Now, it's probably a good idea for us to use the exact value. Oh, let me square that. And what do I mean by that? If we put the square root of 38 squared minus 22 to the second power, and we push enter, we're going to get that decimal. And yeah, it's roughly 31. And we can use that, but I'm not sure how close we could get. We can try it. Okay, in fact, let's do it now. But let me write out what we're really going to put in the calculator, okay? We are going to put in the calculator tangent, inverse, and we're adding these. Right now, we're saying that that is 31, okay? So that means from, not sure what's going on here. There it is. From C to B, that entire distance would be 31 plus the 15. Okay, we need the whole distance. So that would be 46. Okay, so tangent, and that's the inverse. So in or tangent, using the inverse, we need the opposite over adjacent. So we would need 22 over that estimated 46. Well, let's see if that gets us what we need, or if we're going to have an error, or, a small error, a small discrepancy, because we estimated the length of A. Okay. All right. So let's say second, that's inverse tangent, second tangent, 22 divided by 46, close the parentheses, and that gives us 25.559. Okay, it rounds to 26. I can kind of buy that, okay? I'd say, all right, that's it. However, let's try something out, because sometimes the numbers will all be super close, and if you don't do it quite right, you might end up with an error situation. Okay, so let's get rid of that 31 and let's do an exact value. So that means under the radical, we need to put this value of 38 squared minus the 22 squared, and that will equal 960. So we leave that all under the radical. Okay. Okay, leave it like that. So then how are we going to put that in the calculator? Well, we're going to do it just like this. In parentheses, 15 plus under the square root 960, and then close the parentheses. So we're going to use this instead of that estimated 46. Okay, so let's pop that in the calculator. All right, so, all right, I'm going to say second tangent, that gives me my inverse, 22, and then divide by second radical, see where I grabbed it, okay? And then I will have 900, I'm doing this wrong. I need 15 plus. So I need the parentheses, so I need double parentheses, okay? 15 plus. Now I have second radical 960 arrow over, and I will need two parentheses to close that out and push enter. And you know what? It's a little bit better, a little bit closer, but not too much. Either way, we have just proven the best we're going to get is estimating 26 degrees. It's a little bit closer, but again, fully honest with you, sometimes that matters. And you noticed it changed it a bit. It does make a small difference, okay? All right, let's go to number 3. Number 3, look at the following diagram. What is the value of BC? Okay, so this is what they want. They want X right here. Okay, now we could solve that if, very quickly, if we had this height right here. And I know that that's a height because we have this 90 degrees. And I also know that if this angle is 90 degrees, the other angle of C is also 90 degrees. Okay. So because of that, and because I know, obviously, because it's a right triangle, if I had the height, then I could use tangent with opposite over adjacent, but I need the height. Can I get that height? Absolutely, because we go over here to D, And with D, the height would be opposite over hypotenuse, which is sine. So we know that we can get H. So sine of 27 equals H over 44. And as before, if we multiply both sides by 44, then on this side, 44 with 44 cancels out. That leaves us H. So we just put this in the calculator to get that value of H. So 44 sine 27 equals 19. Okay, it's roughly 20. And it's close enough to 20 that I'm okay rounding. So I'm going to say H equals the 20. And I'll be fine with that. All right. So now what do we really have? Well, I see something. Look at A, option A. They're trying to see if you follow through. Okay. Did you complete all of it? Because this is multi step, obviously. So that's just not going to work. Okay. All right, now what do we do? Well, we know everything that we need. So we can use tangent of 50 and use opposite over adjacent, okay? So tangent of 50 equals, opposite is 20, 20 over x. Now this is going to be a little bit more to it. We did one of these earlier, so we'll be okay. Divide both sides by that x. I'm sorry, multiply. Whoops. Multiply. And then these cancel out. So let's rewrite that. So we have x tangent of 50 equals 20. So obviously now what we do is divide both sides by that tangent of 50. And what does this give us? Well, tangent 50 over tangent 50 obviously cancels out. So over here we have our x, and then this is what we put in the calculator, and that should give us something valid. Okay, 20 divided by, oops, yeah, tangent, yeah, for some reason I thought I had the wrong thing. Okay, and double check, that should be it, and there we go, that is the correct option. So the only thing is, I think this might be a typo. Because look at the rounding. I think that should be a 9 instead of a 6. But I can double check that for us. And even with that, that is, it has to be it. It's the closest option. There may be a slight. Oh, you know what that is? That's the rounding error. Yes, that's why. We have a rounding error, and I mentioned that. I said I was okay with rounding that. Let's try it without the rounding. So this is what I'm going to do. I'm going to go up and capture what we rounded. See, it's right there. Okay. I'm going to enter and bring it back down. Now I'm going, because instead of 20, I'm using that, and I divide by the tangent of 50. So tangent, oops, 50, close the parentheses, push enter. There we go. See, and this is why I mentioned before. I'm a little uneasy sometimes by rounding that, being so snappy with my rounding, because it can make a difference. However, we fixed it. It wasn't a big deal. And obviously, B is our answer option. Okay. All right. Let's look at number 4. All right. Look at the following diagram. What is the value of CAD? All right. Let's make sure we know which angle we're talking about right here. let's do a better color for, okay, right, this angle right here, this guy. Okay, so let's see what we have. What can we do? What is that angle? Okay, so we have the 90. All right, well, if we get this height again, just like we did before, then we can use Pythagorean theorem, use the height, and we will not round. We'll use that exact value that we get, whatever that is, and then we can just use cosine. So we're fine. All right, so let's do that. Okay, so first let's call this height. We have height. So the height equals all under the square root 8 squared minus 5 squared. And I'm seeing that that would be a decimal. So let's go ahead and do an exact value. Okay. So 8 squared minus 5 squared, 39. So this is what we're going to use for height. Okay. So that means we have adjacent over hypotenuse. Yes, which is definitely cosine. Okay. All right. So then we have cosine of, we'll call it A, because actually we want a degree measure. Now that's the difference here. We don't, okay, I'll write it out, but to find the angle, we're going to have to use the inverse cosine, okay? So if we had cosine, that would be the square root of 39 over the 14. But we want A. So to get A, we know A equals the inverse cosine of square root of 39 over the 14. Okay, so let's put that in the calculator and see what happens. Okay, second cosine. All right, and now we need second radical 39, and we have to scoot over and divide by the 14, close parentheses, push enter, and they are rounding. Definitely rounding. And I figured there would be rounding. That's why I didn't want to round the square root of 39. Use exact measure so we get the closest we can, and it does round up. Okay, so that would be option B. Okay, this is the last question for this video. And thank you everybody for watching and liking videos and sharing videos. Sharing what we have so other people can watch them, take advantage of anything that's helpful. And thank you again for subscribing. Happy testing.